Problem 1 says estimate the area under the curve for f of x equals 4 minus x squared between x equals 0 and x equals 2 using left endpoints and two rectangles of width 1. So in this problem, I was actually given the width of each rectangle, so I don't have to calculate it. So delta x equals 1. The heights of each rectangle are going to be f of c, where my ck values, right, we need to figure this out. So this says to use left endpoints. So my calculator, or my rectangle widths, are going to be from 0 to 1 and 1 to 2. Those are my subintervals. Right, because n equals 2. Left endpoints means start on the leftmost side of my first rectangle, draw the height up to the function, and then carry the rectangle over and complete it. For my second rectangle, I start at the left side, which is 1. The function touches right here at 3, so the height of this rectangle is 3. So the area of these two rectangles are what we're going to use to estimate the area of the region. So our CK values here are 0 and 1 because we use left endpoint. So those are the values that I would in theory plug into my function. I have the formula here and I could plug them in, but I also have the graph. And fortunately for this, the graphs look nice and pretty. So f of 0 is 4. That's the height of my first rectangle. And f of 1 is 3. So that's the height of my second rectangle. So the area is summing up the base and height of each rectangle. So the base was 1, the height was 4. Here the base was 1 and the height was 3. So the approximate area, and we really should do this, squiggly parentheses, is approximately 7. It is not the true area between the graph, and it is, in this case, we can see an overestimate. I know it's an overestimate because I captured more area than I actually had in the region itself. So the goal is to just find the region between the curve and here, but I grabbed a little bit extra.